All right, guys. Today we're just going to do a quick lesson on the water cycle. I know you know about this stuff, but it's essential for understanding the whole process of meteorology and how water gets up into our atmosphere. So I'm just going to do a really quick thing. We're known as the blue planet. We are a planet that has water in all three states, and that is exceptionally rare in the universe. And we've talked about this a little bit with astronomy. This whole idea of a Goldilocks zone, that Earth is at a really perfect distance away from our sun relative to our sun, which is an average star. We're at a distance of 93 million miles, or 1 AU, and therefore we fall in what's called this habitable zone. A little too far away and a little bit too close. Obviously, you're not going to have life on Earth because it's going to be too cold or too hot. So hence the Goldilocks zone. Mars is a little bit outside of that, and Venus is a little bit too close, obviously, and therefore no water there, at least not in its liquid form or in its gaseous state as we have here on Earth. There's also something called the galactic habitable zone, which is more of an astronomy topic, but the idea is that we're at a good distance away from the center of the Milky Way galaxy. Too close to the center, and it's going to be pretty dangerous as far as stellar explosions and stuff like that. Anyway, we just so happen to be sitting right here. And isn't that interesting? Okay, so that's something to think about, something to consider, that water is a unique substance on the Earth, and there's a lot of really interesting facts about water. Most of our fresh water is trapped in glaciers, which are slowly melting and obviously going into our oceans, and therefore they're becoming salt water. Interesting that we exhale quite a bit of water as you breathe, and you probably notice that on a cold day, that you make a little cloud in front of you. One thing that I learned about this past winter when I had my ice rink in the backyard was that hot water can freeze faster than cold water. And so I was running water from my hot water heater out to my ice rink in my backyard because of this Mpemba effect, which was the idea that hot water freezes faster than cold water under certain conditions. And that is a really interesting thing. You can go down a really long rabbit hole as far as understanding this. Sometimes it works and sometimes it doesn't, but it definitely worked on my ice rink in the backyard. All right, anyway, with that being said, water is a very precious thing. Obviously, it's not completely available to us. Fresh water is really a unique and necessary thing for life, obviously. And there's only really 1% of it on the Earth's surface. Most of the water is trapped in ice, and most of the water is in the ocean. So we only have a little bit that supports our human consumption. Okay, and you can see this kind of graphic that shows all of that. So that's just distribution. That's not really necessary for our meteorology ideas here, but I figured I'd throw that in there just because it's kind of interesting. Here's another interesting picture. If you took all the water on the Earth, so all the oceans, all the lakes, all the rivers, and even out of the atmosphere, that's what you would get, that little tiny ball of water. So even though we are the only planet that has it, it's really not that much when you compare it to the size of the Earth. But again, essential for life. Okay, the other question is, where did all this water come from? And this is theories that they have mostly are outgassing from volcanic eruptions, where early on in Earth's development, a lot of volcanic eruptions put a lot of water from underneath the ground out into the atmosphere. So that's one theory. Another theory is this carbonaceous chondrite idea. I'll put a video up if you want to check that out. It's kind of cool about that. Now, this is the essential slide and the most important thing for today, the hydrologic cycle. So the idea is water cycles through the Earth in this process, this never-ending cycle. And the big takeaway from this is the whole process is really driven by energy that we receive from the sun, which we just got done talking about. That's why we discussed that first. So radiation received from the sun is going to heat up our atmosphere, and it's really going to be the driving factor behind this whole process. And this is very elementary to you, that water evaporates, goes up into the atmosphere and precipitates down and then runs off. But I want to show you a few more details about this whole process because it can get pretty complicated as well. Okay. Now, the one big thing I want you to be aware of, and this is right from your textbook, so I'm just going to highlight this from your textbook. If you took all the water out of the atmosphere and then condense it and make it rain, it would cover the Earth's surface with about 1 inch of water. So there's really not a lot in our atmosphere, and it's kind of randomly distributed. So there's no real, pockets of definite, like this is all where the water is. It moves around our atmosphere. But if you were to cover the Earth, it'd be 1 inch of water. So kind of interesting. The other thing I wanted to highlight here is up here in the textbook. It says, in all, evaporation and transpiration from continental areas amount to only about 15% of the nearly 1.5 billion gallons of water vapor that annually evaporates into the atmosphere. The remaining 85% evaporates from the oceans. And that's a really big takeaway. Most of the water is evaporating from oceans, not from our lakes and not from our rivers. It's like mostly oceans. And that's key because that helps us understand a little bit more about climate and the ocean role in climate. So we'll get to that a little bit later in the school year here, but I figured I'd point that out to you. Okay, back to this. Now, what I gave you in class is kind of a picture of this hydrologic cycle. This one's from your textbook, fairly simple. You see the processes of evaporation and precipitation and transpiration and condensation, all these TION words. But I want to give you a little bit more detail, and so I gave you this picture right here. Now you guys have blanks over top of this. So let's fill out this sheet that I gave you guys in the classroom. I'm going to zoom in on this so you can see this a little bit better. A bunch of these processes you are familiar with, but some of them I think are maybe a little new to you. So let's start here. We just mentioned that the water evaporates from the oceans. The most, 85% of evaporation comes from oceans. And so this box right here is evaporation from the oceans. And again, that's the majority. The water that's coming down out of this cloud is obviously precipitation. I think you guys are aware of that one. An interesting fact is that, not all the water that precipitates out of a cloud actually reaches the surface. A lot of it re-evaporates as it falls. And so this arrow right here representing that is evaporation as well. So you have some re-evaporation. Now, in order for it to turn into a cloud is made up of tiny little water droplets, billions of them. And so in order to change from a gas, right, once it evaporates, it's a gas or a vapor, to change back into liquid water droplets, we call that condensation. So that bubble right there is condensation. Now up here, you'll see this arrow kind of moving across the page. I'm going to delete that one. That's also evaporation. Some of the water in the cloud will evaporate up at higher altitudes, and so you'll see that right there. Moving over to the top right-hand corner, again at the very top right-hand corner, you have this box, and we call this transportation. Basically, we're talking about moving these clouds from over different landscape, different areas, from maybe over the ocean, over land, over the mountains. We're just transporting them at high altitudes. Okay, let's come down from there out of the clouds, again falling as a different form of precipitation, but that is precipitation in the form of snowfall up there, which is going to contribute to our glaciers that are up on top of the mountains. And remember, glaciers make up a majority of the fresh water on Earth. 15% is about that much locked up in the ice up there. Now, we also have this process right here above the mountain from this glacier, from this snow that's been settled for a long time. Some of it will go back up into the atmosphere, and we call that process sublimation, turning from a solid, ice, directly to a gas as water vapor up in the atmosphere. So that's called sublimation, just so you're aware of that term. You might know that sublimation is the process by which dry ice changes, right? Dry ice will sublimate. But water can do that under certain conditions as well. This process right here, going from the gas form back to solid form, is called deposition. It's like the opposite of sublimation. So gas to solid is deposition. That's what happens on your windshield early in the morning when you have a cold morning. The water in the atmosphere hits your cold windshield and forms frost. This one I forgot to cover. That's condensation as well. You can see the water vapor here as a gas, which you can't see, but now it's visible. It's liquid water droplets in this cloud right here. All right, we have another arrow coming out of the tree here, and all plant life takes the process of what's called transpiration or evapotranspiration. Water returned from these leaves after they use it in the process of photosynthesis will return back into the atmosphere in this transpiration process. Okay, coming down the hill here off of the mountains, we see in the background kind of a lake and some rivers and streams there. That's running off the landscape. So all this melt that might come off these glaciers over time is called runoff. Right here we have a lake, and you can see that lake has an arrow going up. That's going to be another evaporation as well. But remember, lakes make up a lot less evaporation than the oceans do over here. Okay, we also have coming down out of this lake, down into the ground, is this arrow leading down, and that's called percolation. Percolation is just water that kind of seeps through the ground, percolates through the ground, and makes up groundwater. Now this box right here is infiltration. That's kind of a similar process to percolation, seeping down into the landscape under the ground. This one right here is plant uptake. You can see the roots underneath the surface there are uptaking that water, and then they're going to use that and then transpire it up into the atmosphere. We also have a box right here that's coming off the landscape. That's another runoff. So we have streams flowing into the oceans, and so a lot of that water is returned from where it went originally. It's coming back now to the oceans. And then finally, we also have this box right here is groundwater. Groundwater is water underneath the ground. Okay, and a lot of groundwater will get trapped there for a long period of time. We take up a lot of that water for human use as well. Okay, so there's your entire water cycle in a nutshell, and hopefully you filled out all those words. You're going to need to be aware of a lot of these words, and we're going to be really focusing on the processes of evaporation and condensation as we talk about humidity, which is essentially a measurement of the amount of water that's in the atmosphere. And that's going to be a big driver of our understanding of making forecasts and meteorological predictions. Okay, so that's it. If you have any questions about anything, let me know.